Hey guys, welcome once more to another fantastic geometry video. This one should be pretty short. We're talking about segments and circles today. There are three different applications that we're going to do. So I'm going to show you the rule, work a sample problem, ask that you pause and work the second sample problem, and then I'll show you the answers to it. All right, starting off with we have two chords. If we have two chords, the procedure is part times part equals part times part. All right, so in this case, that means that AB times BC equals EB times BD. So it is one part of the first chord times the other part of the first chord equals one part of the second chord times the other part of the second chord. So applying that, down here I would say 5 times 12 equals x times 10. So this is 60 equals 10x. So x is equal to 6. Just like that. Pause the video now, work example 2 on your own, and then come back for the solution. All right, welcome back for example 2. Again, part times part equals part times part. So 12 times 6 equals 8 times x. 12 times 6 is 72 equals 8x. Divide by 8, of course. And I get x equals 9. Just like that. So if it's two chords, we go part times part equals part times part. Next application is, what if it is two secants? So in this case, secant is a line that touches the circle twice. In this application, we say outside times whole equals outside times whole. So we take the outside portion of the secant, which is AB, times the whole secant, which is AC. And the outside portion, AD, times AE. Outside times whole equals outside times whole. So to solve an example of that, I'm going to take the outside, which is 7, times the whole part, which is 7 plus 12. It's going to be equal to the outside, which is 6, times the whole part, which is 6 plus x. So outside times whole equals outside times whole. So here we go. I'm going to have 7 times 19, which is 133, is equal to 36 plus 6x. Don't forget to distribute the 6 to both places. Subtract 36. That's going to give me 97 equals 6x. So I divide by 6. 97 over 6 is an improper fraction. It's also can't be reduced any. So x is equal to 97 over 6, which is equal to 16.16 repeating. 16 and 1/6. That's what that is. So there we go. Pause it now, work example 4, and then come back for the solution. Welcome back for example 4. We have 8 times 8 plus x equals 6 times 10 plus 6. So this is 64 plus 8x equals 6 times 16, which is 96. 6 times 16 is 96. So I'm going to subtract 64 from both sides. It's going to give me 8x equals 32. So divide by 8 gives me x equals 4. So 8 times 12 is 96, and 6 times 16 is 96. It checks. One more to go. I told you this one would be quick. Here, this is when we have a secant and a tangent. And in this case, we say it is the tangent portion squared is equal to outside times whole. So in this case, it would be jk squared, so jk times jk equals jl times jm. Okay, so let's apply that. Tangent portion squared, x squared equals 7 outside portion times 7 plus 9, which is 16. So x squared equals 7 times 16. That gives me x squared equals 112. So x equals the square root of 112. I already know that 112 is 7 times 16. And of course, 16 is 4 times 4. So that means that x is equal to 4 square root 7. All right, take some time, do example 6, pause your video. And welcome back for the solution to example 6. Here we are going to say 5 times 5 plus x equals 9 squared. So 25 plus 5x equals 81. Going to subtract 25. Gives me 5x equals 56. So x equals 56 over 5. Again, improper fraction can't be reduced. So we could give it a decimal approximation though. That's actually the exact same thing. So 56 over 5 is equal to 11.2. Thank you for watching. I hope this has been edifying for you and for me as well. And we'll see you in class.